All right, welcome back. So today we are going to be talking about the root of graphing linear equations, and this is called slope-intercept form. If you go home and you ask anyone who has taken algebra before, what is slope-intercept form? I guarantee you that 90% of them are going to say y equals mx plus b. And today we are going to be talking about what that means, what it is, what is slope-intercept form, and how are we going to be graphing linear equations with slope-intercept form. Now, we talked about direct variation prior to today. Direct variation is when you have y equals kx, right? Well, guess what? Slope-intercept form is direct variation, except it doesn't go through the origin, which is where we get an additional value. But we're going to talk about why that is in just a moment. But without further ado, let's begin. So, an equation that's written in slope-intercept form has y equals mx plus b. And what that means is our x and our y still stand for the ordered pair, right? We have x comma y, we have a coordinate plane, an x-axis, and a y-axis. So nothing has changed yet. M stands for your slope, which is what we've been calculating before. When we're given a line, we find the slope of that line. Well, now we're going to be using the slope to graph a line. So we're going to be going backwards now. And the letter B stands for what's called the Y-intercept, which is where a line crosses over that y-axis, which is how before we were finding the x and y axes, or the x and y intercepts of standard form to practice how to find the y-intercept. Well, guess what? It's come full circle now. So we're going to be graphing y equals mx plus b, where m stands for the slope and b stands for the y-intercept of that line. We don't necessarily care about the x-intercept for slope-intercept form. We want to be talking about the y-intercept. So if we look down your guided notes, there are a couple different examples in there that I want to go over. So it says a line has a slope of -4 and a y-intercept of 3. We want to write the equation in slope-intercept form. Well, all we're going to do is substitute in those given values. We know that slope-intercept form is y equals mx plus b, pardon me. Oh, I'm a poet and you didn't even know it. B, pardon me, look at that. So all we're going to do is substitute the given values for m and for b. Again, m stands for your slope and b stands for the y-intercept. Well, we know it has a slope of -4 and a y-intercept of 3. So we're going to rewrite it as y equals -4x plus 3. Notice, we still have y and x are just chilling by themselves as variables. We haven't changed that, right? We haven't changed the x, we haven't changed the y. We're using the y-intercept, which is much different than just y. The xy is going to be showing us ordered pairs that will be on that line, hence why we leave x and y all by itself. All we do is substitute in the value of m for -4 and substitute in the value of b for +3. Now, real quick, I'm going to add in some notes here. Let's say we had the y-intercept had a value of -3. The way we would write this is y is equal to -4x minus 3. We do not write plus -3. We don't write that in algebra. Okay, we want to be concise here. So we write -3. So it's y equals -4x minus 3. If your y-intercept has a negative value, we write a subtraction sign. If it has a positive value, we write an addition sign. Awesome. So now he's going to ask you, hey, a line has a slope of 2 and the ordered pair 3, 1 is on that line. We want to write the equation in slope-intercept form. So when we look at what we're given the slope, which is our m value. We're given an ordered pair, which is our x, and our y value. So we need to find the y-intercept. So in order for us to do that, to find that y-intercept, we have to write out our equation, y equals mx plus b. And we're going to substitute in the value for m, which was our slope, which is 2. We're going to substitute in the given values of x and y. We get that from the ordered pair. Remember, the ordered pair, it's x comma y. If it's x comma y, we substitute in 3 for x, 1 in for y, and then we're going to find the value of b by doing some algebra here. Solve for b, we get that b is equal to -5. Now that we have our b value, we were already given our m value, our slope value, we can now go back and write out our equation. Remember, it's y equals mx plus b, so we substitute in the slope value and the y-intercept, and we get y is equal to 2x minus 5. Notice something real quick. Notice something here. We started out knowing that's y equals 2x plus b. So our slope times x. Well, guess what? We still have 2x minus 5. All we did there was find the b value and replace that b with the value of -5. Awesome. With this, please work on the front side of the guide notes, problems 1 through 6, and resume when you are ready to move forward. All right, you've listened to my voice. That means that you have worked on the front side of your guided notes and you are ready to move forward. So, backside, we're going to start out by, you can use the slope and this y-intercept to graph a line. Remember how I said before we were given a line on a graph and we calculated the slope? But we're now going to go backwards from there. We want to take an equation written out in slope-intercept form and graph it on a coordinate plane. So if you are given y equals mx plus b, then you can start to go from there. But sometimes you're not going to be given that. Sometimes you're going to be given an equation that's written a little bit differently. Let's say you're given 2x plus 6y equals 12, and we want to write that in slope-intercept form. Then we're going to graph the line. So the first thing we need to do is we need to solve for y. We want to get that into y equals mx plus b. I actually went down a bit too far there, but here we go. So we have 2x plus 6y equals 12. We want to subtract 2x on both sides. We get 6y is equal to -2x plus 12, and we divide by 6 on both sides. So we get that y is equal to -1/3x plus 2. This is now in slope-intercept form. It's y equals mx plus b. The m, if we're looking at this equation, is going to have a value of -1/3, and our b, our y-intercept, is going to have a value of +2. The next thing we need to do is we need to find the slope and the y-intercept, which is what we actually just did. Woohoo! Let me see if this deletes now. There we go, perfect. So our slope has a value of -1/3, and our y-intercept, or our b value, has a value of +2. Now we can take this and we can graph our actual problem here. We can graph this equation. In order for us to graph the equation, the first thing we're going to do is we're going to plot the y-intercept value. We're going to plot 0, 2. We know the y-intercept of this line is +2, meaning it's going to be hitting that y-axis at +2. So we know that for a fact. So we can plot that coordinate point, 0, 2. We can go 2 on the y-axis and boop, place 1 point there. Now that we've done that, we apply our slope. Our slope has a value of -1/3, which means we're going to count 1 down because the rise is negative and go 3 right because the run is positive, and then plot another point. So we go down 1, right 3. 1, 2, 3, boop. Now we have 2 points, which means we can now draw the actual line. So the first thing we do when we're trying to graph in slope-intercept form is 1, make sure it's in slope-intercept form. If it's not, we have to rearrange that equation to get it into slope-intercept form. But once it's there, the order in which we graph this line is we plot the y-intercept. We know that coordinate point. We know that value. The y-intercept is when it crosses over that y-axis. In our example, it had a value of +2. So we found +2 on the y-axis and put 1 point there. Now we're going to start from that y-intercept and we're going to apply the slope to get our second point. Once we do that, we now have 2 points and we can create a line. This is going to be much quicker to graph linear equations in slope-intercept form than it is in any other method that we have done thus far. The more that we practice this, the better off we're going to be, and we're going to practice, practice, practice. All right, folks, great job with this. With this in mind, please work on problems 7 through 10 on your guided notes. Great job today, folks. I will be talking to you soon. If you have any questions, please let me know. But other than that, have a good one.